Okay, I think we're going to get ready. I think we're going to go. So why don't we get started? Welcome. My name is Marjorie Kaplan. I am co-director of the New Jersey Climate Change Resource Center here at Rutgers University, and I'm going to be your moderator for today's Climate Academy, focusing on our recently released report entitled The State of the Climate New Jersey 2024. I'm joined by my co-director, Lucas Markson, who'll be assisting me in monitoring your chat and questions for our distinguished panelists. And today's webinar is going to last until 1 o'clock. Other than today's presenters and our Rutgers team, you're all muted. So to communicate with us, please type your questions into the chat box. Please send your notes to panelists, as that ensures all of us working behind the scenes today will see your questions. We are recording today's webinar, and it will be available on the New Jersey Climate Change Resource Center website. And I'm going to get that link in the chat right now for you. I'll put it in a minute and assume everyone stays on time. We have allocated a chunk of time at the end to get to your questions. So please, again, put them in the chat. The actual State of the Climate report can be found on our website, and I will also put that in the chat in a minute. I also want to thank our colleague, Dr. Oliver Stringham, for his help with today's webinar. So today we're pleased to have three wonderful speakers. We have Dr. James Shope from the New Jersey Agricultural Research Station and Experiment Station and the Department of Environmental Sciences, Dr. Anthony Broccoli, Distinguished Professor in the Department of Environmental Sciences, and Dr. David Robinson, who's the New Jersey State Climatologist and Distinguished Professor in the Department of Geography. Dr. Efthymios Nikolopoulos is unable to join us today, but Dr. Shope is going to be covering what Dr. Nikolopoulos would have presented. And so with that, I'm going to invite Professor David Robinson to turn on his camera and his microphone to kick off our event today by discussing 2024 in review. So take it away, Dave.
Okay, Marjorie, I hope everyone can hear me. Let me get my slides going. Are you seeing my slides?
Not quite yet.
Well, they're up. That's the... Let me share again. I think I may have shared too soon. You were still on with it, Marjorie.
Right, we see those, Dave.
And you can see it now?
Yep, we see the monthly precipitation departures.
Terrific, terrific. Except that's not what I want to show. There we go. All right. Thank you, everyone. Sorry for the little glitch there. Pleasure to be here. Good afternoon, everyone. I'm going to give you a quick, less than 10-minute overview of where things stood in 2024. Going to give you a little bit, since we're halfway through 25 already, a little bit of what I consider some of the highlights of this year so far. But really, 2024 in the world of weather and climate in New Jersey was really focused on two main things. Otherwise, it was not the most exceptional year when it came to storms, snow, hurricanes, and such. And those are the first two in the top 10 lists that we in the State Climate Office produce every year for everyone's fun and enjoyment. But the first two are really critical. It was the drought. I'll show you a few slides about that, so I won't spend any more time on it this very second. But we had the drought in the second half of the year, and then we had once again a year that was above not only the 1991 to 2020 average, but of course, well above the period of record average for New Jersey that goes back to 1895. So it was, again, the second warmest year on record, something we've seen pretty often. We had storms, and you can see one that made number 3 was way back in January. Remember, that's January of 2024, so we're looking back a ways. Wind often came into our question box, if you will, in the State Climate Office last year. There was one instance where the winds just wanted to blow in the opposite direction they normally do, a persistent period of winds blowing from east to west back in September. But overall, there was the discussion of winds last year. Is Jersey getting windier? We haven't seen that in our records, but certainly we had episodes quite often of some pretty persistent winds. Um, Again, general absence of severe weather, but locally, and we've seen it this year, we see it most every year. We had some real memorable deluges that led to some flash flooding. In the minor trivia box, the high pressure we had back in on December 14th, we hadn't seen that pressures that high in New Jersey since 1981. So that was quite a strong Arctic blast of high pressure and really set the scene for what was a colder than normal winter, unusual in itself in recent decades. And then some other things, an interesting band of snow, which you'd more commonly find in the Wasatch of Utah with very low water content, very fluffy snow, a surprise snow event. It took a long time for the temperature to get to freezing last fall, particularly in coastal areas and urban areas. And then really what proved to be the only snow event of all of this past winter going through into 2025 that deposited at least 10 inches of snow somewhere in the state was up in the Northwest Hills in November when High Point Monument had 20 inches of snow, the largest amount of snow measured on record in New Jersey in the month of November. Here's turn into drought, a tale of two halves of the year. The scale is the same on both of these graphs, and you can see it below in inches. And you can see the first half of the year, pretty wet. Above normal precipitation, we should be in the low 20s for the first half of the year for precip. The second half of the year was very, very different. Now you'll notice the northern half of the state was a little wetter in the first half of the year and a little less dry in the second half. It was the South that really felt it the most, particularly with this drought. But this was probably the most severe drought because every drought's different. In New Jersey, the most severe one since the turn of the century drought, which culminated in 2022 when the state had an official drought emergency. It only became a drought warning this time around as issued by the Department of Environmental Protection. But we were well below normal in the second half of the year, and that included the third driest September on record and the driest of any month since 1895 in October, when essentially no rain fell. We were talking a few hundredths of an inch instead of 3.5 to 4 inches. And you can see it right here with our time series. You can see this on the state climate site, updated every month. So this is what we had posted back in January, showing the previous 12 months. And there you can see how very dry September and October was. We began to recover a little bit in November and December, but they still remain below normal. And as a matter of fact, since then, only May was above normal precipitation, and July had above normal, but every other month to start 2025 has been below normal, and it's looking like August is going to be as well. Looking at temperature, these are the top 10 warmest years in New Jersey based on several dozen stations averaged and weighted across the state. And you can see how 2024 was the second warmest. And notice the prevalence of 20 as the prefix to all the years except 1998. But we have gotten considerably warmer in New Jersey in recent decades. Looking at temperatures for the 12 months of 2024, you can see they were almost all above normal. December was below. This year, January and February were below as well. But the 2025 is running above normal. But let's first look back to last year, and you can see where you see the rankings. Those are the rankings going back to 1895. The departures you see here, the red being above, the blue below, are departures from the 1991 to 2020 means. So looking at it either way, we were really cooking back in 2024. And this is a graph we produce in the State Climate Office in cooperation with the New Jersey Department of Environmental Protection. We've been doing this for a number of years. And what you see in the top there are the 5 warmest and coldest months of years of every month of the year going back to 1895. If it's blue, it was a month in the top 5, excuse me, for cool, for being below normal. And if in reds, shades of red, the top 5 for warmth. And one thing, this is one, in my career, over 30 years as a state climatologist, this is the statistic that just knocks me away. The last time New Jersey had a below average month of temperature that ranked in the top 5 for cold was December of 1989. Since that time, we've had 48 months rank in the top 5 for warmth. And you can see the imbalance in the top figure. The bottom figure is for precipitation. And there you'll note it's more widely dispersed. New Jersey is getting wetter in recent decades, but it's not as if there's a leaning for many, many months coming in with the top 5 for wetness. But what I note with this figure is the darker shades of red and blue. Those are the ones that rank first or second wettest, driest. And you see more of them towards the right side. So we've seen more extremely dry months, last October, for instance, and extremely wet months. So there is a little view of well, let me back up for a second, of 2024. Let me finish up by quickly, because I think I have a minute or so left, where we are in 2025, because I know some of you no doubt are curious about that. So this is kind of my top couple, and most will probably make the top 10 when we do a list for all of 2025. First of all, let's see here, was the drought. I mean, the drought continued through the winter. January was 3rd driest. We took a drought-busting month of May to really help us greatly, where it was the 7th wettest May on record. So we're out of major drought concerns, but it's dry right now. So we're going to have to keep an eye on late summer and as we go into fall. There was the wildfire, the Jones Road wildfire on April 22nd. It hadn't rained in 10 days down there. There were modest westerly winds that afternoon. The fire was set accidentally, but it was set by humans, ignited by humans, and heroic efforts of firefighters helped to contain the fire. The wind slackened during the evening, and what could have been a terribly disastrous situation only became turned out to be a dangerous one. Then we turned to July with the flash flooding, particularly up in the Plainfield area. And we're talking Somerset, Middlesex, and Union County, tri-county area, which resulted in several drowning deaths and considerable flooding. There have been severe storms in July that killed 2 people from lightning strikes and 3 individuals from tree falls during severe straight wind events. They would probably take the list. I should add warmth too. We ran 16th warmest first half of the year. And March, June, and July all ranked in the top 10 for warmth. So with that, I will not continue on. I will stop sharing and pass it over to James.
Yes, James. Dave, thank you. That was fantastic. James Shope is going to provide us with updates on historic climate trends and future projections for New Jersey.
Yes. Thank you, Dave, for that fantastic overview of 2024 and part of 2025. I'm going to, as Dave did, try to do all this in 10 minutes, so I may have to run through a little bit fast. So I want to start with discussing global climate drivers before we get into some of the bigger trends that we've been seeing in New Jersey related to climate variables like temperature, rainfall, and the like. So climate change, or at least anthropogenic climate change, is driven by the combustion of fossil fuels. We're talking about stuff coming from coal, petroleum, and natural gas. And we primarily discuss carbon dioxide, but there's a number of other greenhouse gases. Now, if we look at the concentration of carbon dioxide in the atmosphere, it's been increasing since we have really good measurements. I have a laser pointer here. Since our measurements at Mauna Loa Observatory in Hawaii in the 1950s, the amount of carbon dioxide in the atmosphere has increased. And you see that we are sitting above 420 parts per million, and that leads directly into warming at the Earth's surface. So if we take a look at global temperatures, this is relative to the average of the last century, so that's why there's some negative and positive numbers here. Global temperatures have risen by about 2 degrees Fahrenheit over the past century or so. But you can see that starting in about the 80s, maybe a little bit before, that increase has been much stronger. It's been much sharper. So while there is year-to-year variability, for example, these little blue dots represent El Nino years, there has been this overall trend that's accelerating over time in terms of global temperatures increasing. And we can actually visualize that spatially. This is just showing temperature change from 1980 to 2015. And you can see that broadly, there's some warmer colors across the entire globe, and it's not distributed the same everywhere. Certain areas are warming faster, such as up in the Arctic Circle area and, parts of Middle East, as well as like the southwestern US into Mexico. And we think this warming trend is going to continue into the future. So this is looking at change in temperatures relative to what we call a pre-industrial period here, 1850 to 1900. And as we look across multiple potential scenarios for how we as humanity change our global emissions globally, we have kind of more happy scenarios where we reduce our emissions kind of here in blue, or ones where they continue to increase here in red. And you can see regardless, they're all in this area of increasing, with what we're more trending closely towards right now based on today's policies being about 2.7 degrees Celsius warmer than that pre-industrial period. And that warming leads to a number of potential hazards like coastal flooding, changes in rainfall patterns that cause drought or flooding conditions, or dry conditions that are conducive for wildfires. But let's focus in on New Jersey, and we're going to start with temperature and heat. Much like the world, temperatures in New Jersey have increased, but in New Jersey it's been more so. So since 1900, temperatures in New Jersey have increased about 4 degrees Fahrenheit, so about twice the global average. And that rate's been increasing at a faster rate in recent decades. So the blue line here is just kind of a linear trend showing that since 1900, we're looking at about 0.3 degrees Fahrenheit per decade increase in our annual temperatures in New Jersey. Whereas if you were to say take that from 1960, that trend is actually closer to 0.7. So you see, again, our temperature increase is I should say accelerating, but increasing over time in recent decades. And as we think about what may happen in the future, under kind of moderate emissions, again, more consistent with our current policies, we expect temperatures in New Jersey to increase by about 4 to 6 degrees by the end of the century, by 2100, compared to 1991 to 2020 average. With higher emissions, that would be closer to 6 to 9 degrees of warming on average for the annual temperature. Those increased temperatures have a number of potential impacts. I don't want to go through all of these, but they can do certain things such as increasing heat exposure and heat stress for individuals, especially in urban settings that are already subject to the urban heat island, which kind of makes temperature exposure worse. We would expect to see an increase in certain types of vector-borne diseases, especially those associated with pests like mosquitoes whose temperature or whose geographic range is constrained by temperature. And they carry certain diseases like malaria, West Nile virus, and the like with them. And higher temperatures can stress our various types of infrastructure, whether it's, say, bridges or our power grids. Now, following global increases in temperatures, we see an increase in sea level. Now, increases in sea level at a global scale are due to multiple things, but suffice to say, as temperatures increase, you have the ocean itself warming, which causes some expansion, some volumetric expansion that we see on the surface of sea level rise, as well as melting of ice sheets, glaciers, and the like. So if we were to take a look at global sea level since about 1900 up until 2020, it's increased by about a quarter of a meter. And going forward, again, thinking about our scenarios of sea level or of climate change here, we see that sea levels are projected to increase by roughly about to 3/4 of a meter compared to 1900. But that's not necessarily what we're experiencing here in New Jersey. What we see is that there are local effects in sea level change that may cause us to experience sea level rise at a different rate. And this is what's called relative sea level rise. Here in New Jersey, this image is showing relative sea level change in inches. And in this case, it's from 1960 to 2020. You can see that we're in a hot spot here in the mid-Atlantic. And in New Jersey, our sea levels have increased by about 19 inches since 1911. So we're seeing sea level rise much faster on our coast. And again, thinking about projections into the future, this is from the 2019 Science and Technical Advisory Report, panel report, that we are currently in the process of updating. But we're looking at, by 2100, in this likely range of 2 to 5 feet of sea level rise by the end of the century on New Jersey's coast relative to the year 2000. So sea levels are going to be higher along our coasts, and there's a number of issues with that. One would be just the kind of flooding from the encroaching tides. You may see more instances of sunny day flooding or tidal flooding, but it also exacerbates kind of our worst events. So for certain events like, say, a nor'easter that produces storm surge, during current conditions, that storm surge acts on top of an existing high tide line. Ideally, homes are built in a way, or businesses or other sorts of infrastructure, in a way that would accommodate this. But with sea level rise, you shift that baseline higher, and all of a sudden your storm surge can go in a lot farther and cause more damage. And we've seen that with Hurricane Sandy, where it's been estimated about 13% of the total property damage in New Jersey, around $4 billion, can be attributed to the fact that sea levels were higher due to human influence. And as we look forward, larger coastal flooding events are projected to become a lot more frequent because of just the fact that sea levels are higher along the coast of New Jersey. Now, going into precipitation and rounding out the kind of big three-ish items that we discuss in the report, rainfall in New Jersey has become more variable as we've gone along. Basically, a larger oscillation between very wet and dry to moderate years. You see that in this graphic here, showing our total annual precipitation in green. But if you were to look at this over a trend, it's been on average about a 7% increase in our rainfall since the early 1900s. Not a really big change. And as we think about projections into the future, we see a similar thing. We're expecting maybe about a 3 to 13% increase compared to this 2001 to 2020 average by the end of the century for moderate emissions. So not a huge change, but you do see a good swath of the US and New Jersey is expected to become wetter on average. Now, where there's a bigger story is in extreme rainfall. In the US Northeast, which broadly from a climate region, we include New Jersey in that, rainfall is becoming more frequent and larger. So this is showing days with 2 inches of precipitation, 3 inches precipitation, 4 or 5 more. And you see an increase across the board. The trends are going up in each one of these since 1958. DEP studies reports have projected the 100-year 24-hour event to be about 2.5 to 10% greater in southern and central New Jersey and up to 20 to 25% greater in northern New Jersey. And the big takeaway is extreme rainfall is going to become more common in the state. And a lot of our extreme rainfall guidance is based on historical observations, but needs to accommodate for this potential change using model projections for future effects. Obviously, a lot of downsides to extreme precipitation, flooding, agricultural impacts, problems with combined stormwater infrastructure. Won't get into that for the sake of time. And to round out this idea about rainfall and storms that will segue into our next section, when we think about hurricanes or tropical cyclones in the Atlantic, we know that warmer waters fuel more intense hurricanes. So as the ocean itself warms and the air above that is also warm and more humid, we expect to see our hurricanes moving forward to become more energetic. So more frequently categories, say 3s and 4s compared to today, intensify more rapidly before making landfall, and virtually all of them are expected to produce a lot more rainfall. And in recent decades, we've been seeing an uptick in kind of above normal activity in terms of cyclone energy or hurricane energy in the Atlantic Ocean compared to what we would consider normal. Okay, so with that overview of our climate trends, I'd like to invite Dr. Anthony Broccoli to come and talk about kind of our featured piece in the report discussing Hurricane Helene's extreme rainfall in 2024 and its parallels to tropical systems here in New Jersey. So I will stop sharing and let you share, Tony. Thank you.
Okay, James, thank you very much. Now let's see if I can manage to do this the way I want to. Here we go. And just change my display settings here. And hopefully you're now just seeing the main slide about Hurricane Helene's rainfall, which was a big event in 2024, and how this can parallel some of the kinds of situations that we have had in New Jersey with tropical systems and very likely will have in the future. So to start out, the overall weather pattern that brought Hurricane Helene to the southern Appalachians involved a trough of low pressure and a cutoff low that was situated over the Ohio, Tennessee Valley, Great Lakes region, and a high pressure system off the East Coast. And what this did was produce a flow from the south that steered Hurricane Helene from the Caribbean and the Gulf up across the southern Appalachians. Now, the reason why this pattern was so important for the impacts of Hurricane Helene is that northward flow of moisture can produce rain well in advance of the actual hurricane. So when you look at the satellite picture on the right, you see the eye of the storm located west of Tampa, but a long plume of cloud cover extending all the way up into the Great Lakes. And underneath that cloud cover, it was already raining long before the rains from Helene arrived. And so there was what we call a predecessor rain event that happened that was a big rain event in and of itself. And then that was followed with the tropical rains with the moisture that Helene brought northward. Now, one reason why Helene was so moisture laden was that the waters over the Gulf were warmer than normal. The map on the left shows the actual sea surface temperature in degrees. The map on the right shows the sea surface temperature anomaly, in other words, whether or not the temperatures there were above or below normal. And the Eastern Gulf was well above normal, 2 to 3 degrees above normal in places as Hurricane Helene passed over it. So that was an opportunity for the storm to pick up a lot of moisture. And that moisture found its way to the southern Appalachians, particularly in western North Carolina, a little bit of northwestern South Carolina, and northeastern Georgia. And here the rains were very heavy. The color scale at the bottom tops out at 12 inches, but in many places there was more than 12 inches of rain. That rain falling over very rugged terrain where people tend to live in the valleys near streams and rivers was what produced such calamitous impacts in this area. And there was a tremendous loss of life, sadly, more than 250 deaths from Helene in the area that was affected, with more than half of them, or roughly half of them, happening in North Carolina. And a lot of details in this chart on the right, but the bottom line for this chart is that in North Carolina, the damages were estimated to be in excess of $50 billion. So a tremendous impact, not only on people, but also on infrastructure. And there are many places in the Western Carolinas where it has taken months and months to recover, and some of them are still not fully recovered. Now, why is this relevant to New Jersey? Well, when we think about tropical systems in New Jersey, understandably, the storm that pops into our heads is Tropical Storm Sandy. Post-tropical cyclone, technically, that's really a technicality that's of more interest to meteorologists and maybe to insurance companies. But in addition to the kind of wind-driven coastal flooding, storm surge flooding that we got from Sandy, New Jersey is also susceptible to rainfall-driven flooding from hurricanes, but also from tropical remnants, maybe storms that have long since weakened in terms of their winds, but not in terms of their rains. And so the conditions that we saw in southern Appalachia could occur in New Jersey. And in fact, we've had situations like that with some past tropical cyclones. So let's take a look at some of these systems. In 1955, we had the impacts of two hurricanes that came roughly parallel to the East Coast, Hurricane Connie and Hurricane Diane. And they combined to produce more than 19 inches of rain at Canisteo Reservoir in the New Jersey Highlands in a period of a week. And as I'll show you in a minute, this produced some of the most damaging flooding on the Delaware River that we have on record. But there have been other more recent storms. Hurricane Floyd in 1999 produced what at that time were record levels of water in the Raritan River Basin, among others. Hurricane Irene in 2011 followed a month that was already extremely wet, would have been one of the wettest months in the history of the state. And then another 6 to 10 inches of rain, widespread rain, was dumped on top of what had already happened that month. Hurricane Sandy was not as much of an extreme rainfall event for most of the state, and I'll show you why in a minute, but there was almost a foot of rain in Cape May County, New Jersey. Fortunately, the sandy soils of southern New Jersey don't produce some of the impacts that we see further north. Henri in 2021, a very localized event, but as much as 9 inches of rain in Mercer, southern Middlesex, Mercer County, being very hard hit. And then Ida, which in 2021, which was also very impactful, including loss of life, but a great deal of damage because the rain from Ida fell in a very short period of time, most of it falling in just 3 or 4 hours, with a total of over 9 inches measured in Hillsborough. So these are some of these high impact events that have happened in the past. Here's an aerial photo of the Lambertville New Hope Bridge after the Connie and Diane rains in 1955, some of the highest water levels recorded. It's nice that the deck of the bridge is above water, but getting to the bridge certainly was impossible given the flooding that was occurring on either side of it. Now, I mentioned a couple of the more recent events, Floyd and Sandy, and the rainfall from these events is being shown here because the rainfall patterns are very different. With Hurricane Floyd, which followed a more typical track of tropical systems that affect New Jersey, in other words, moving parallel to the coast, there was a swath of heavy rain that was just to the left of the storm's track, and that produced devastating floods in North Carolina, but also a great deal of flooding here in New Jersey. With this kind of pattern, with a trough to the west that steers storms along the coast, we typically see the heaviest rains to the left of the storm track, or in this case, to the west of the storm track. With Hurricane Sandy, the heaviest rains were also to the left of the storm track. But because Sandy took this unusual track coming from the east-southeast, those heavy rains were confined to extreme southern New Jersey and the Delmarva Peninsula. So much less of a heavy rain impact over most of the state. So what are the main takeaways from what we've talked about? Well, first of all, there are a number of processes working together, like warmer coastal waters and predecessor rain events, that can exacerbate the impacts of hazardous storms, greater destruction, and unfortunately, even loss of life. Even though we think of tropical systems as mainly a coastal process, and we can attest to that today because even though it's far offshore, Hurricane Erin is producing wind gusts between 40 and 50 miles an hour along the New Jersey coast, along with coastal flooding. Coastal flooding is not the only impact we can see from tropical systems. Helene in North Carolina, post-tropical storm Ida here in New Jersey in 2021 are reminders that inland areas can be subject to extreme rainfall, flooding, damage, and even loss of life from tropical systems. And as the world and its oceans warm, since those ocean waters are the source of energy for tropical systems, but also the source of moisture for tropical systems, those systems will bring greater rainfall that can cause river flooding well away from the coastline. So thank you, and I will now stop my sharing and turn things over to James.
All right, thank you, Tony. So as Marjorie mentioned, unfortunately, sorry, give me one second. Unfortunately, we were unable to be joined by Dr. Nikolopoulos today, so you get a double helping of me talking to you. But I'll be discussing a few of our other kind of sidebar pieces from the report, starting with future drought projections for New Jersey. So, New Jersey is a fairly wet state, but drought still impacts us and historically has impacted us pretty severely, especially in the 60s. So it's worth thinking about how droughts may change in New Jersey and how our rainfall availability may change. Now, when we discuss drought, there's 4 big types of drought. Well, you can split it a few other ways. There's agricultural drought, considering that there's not enough water in the soil available for growth of crops. Socioeconomic drought, that happens when water supply is too low to support human environmental needs. Hydrologic droughts, when there's a lack of surface or subsurface waters, and then meteorological droughts. Basically, when an area receives less rainfall than normal or has greater amount of evaporation compared to normal. And we're going to be discussing this meteorological drought. And the main reason for that is it's a lot easier from, say, climate models and the like to quantify changes in a meteorological drought versus agricultural or hydrological droughts that require a lot more understanding and simulation of other processes that may be happening beyond just rainfall or evaporation. So when we think about it, how do we calculate a meteorological drought, or how do we even just conceptualize one? So I have this little fun graphic here showing kind of normal conditions. And we have a certain amount of average rainfall that's coming into, in this case, the state of New Jersey, and that's a big bucket here. And water leaves that system through a number of different ways, but if we want to think about it in terms of meteorological conditions, water comes in as rainfall and leaves as evaporation or transpiration. Certainly there's other ways water leaves the system, gets aggregated into a river, goes out to the ocean, or maybe people, pump it from groundwater and drink it. But in a very simplified sense, you have this in and out box model. So you can have a meteorological drought if you have a water deficit due to lower rainfall. So in this case, you have less rainfall, so your amount of transpiration or evaporation remains the same, and so you lose out on your water. And if that persists for a long enough period of time, that's when you get into drought conditions. You can also have drought conditions where you have an average amount of rainfall, but your transpiration or evaporation is enhanced, and maybe this is due to warmer conditions. moving forward, as we think about changes in New Jersey, especially with it projected to be warming into the future, we expect to see this kind of being the big question mark more so with when it comes to drought and potentially driving greater drought. And then we have the kind of combined of these, less rainfall associated with warmer conditions that enhance transpiration or evaporation. And so you see throughout this, our kind of water supply in New Jersey is diminished. So that's the conceptual underpinnings of how we think about a meteorological drought. So what we've done is we've used the standardized evapotranspiration index. It's called SPEI. That represents the difference between precipitation and potential evapotranspiration at any location you want to look at. So we were looking at, as you'll see in a second, the counties of New Jersey, and you can evaluate whether you're in drought or drought-like conditions over timescales of, say, months, seasons, or years. Now, for our purposes here, we're just looking at seasons, but you can conceptually look at it over a longer period of time. And particularly, we've in the report look at the winter, so we're defining that as December through February, and the summer, June through August seasons. And the way that we are presenting that information is looking at the percent of time that we are in drought, kind of in historical conditions during those seasons, and what the models say that would be like in future conditions, and kind of quantify the difference between those two to give us a sense of how much more time our counties in New Jersey may be spending under drier than normal or potentially wetter than normal conditions during the winter and summer seasons here in New Jersey. So this is the main graphic from this little sidebar piece for this calculation. And we're looking at percent change for a moderate greenhouse gas emission scenario. So again, following our current policy trends at least as of November 2024 at a global scale. For a mid-century period, so kind of an average of what's happening from 2041 to 2070, and an end-century period of 2071 to 2100 for our winter and summer seasons. So again, we can break this apart by whatever geography we really want to, but for this purpose, we broke it apart by county in New Jersey. And there's some interesting takeaways that we have here. So first off, when we're thinking about changes in rainfall moving forward, the projections in changes in annual rainfall aren't really that different. But when we start breaking it into projections by season, that's when we start to see these effects and how they could affect drought. So if we were to take a look at what's happening in the winter for both the mid and end century, we actually see across most of New Jersey, some funky stuff happening down here in the south, an increase in wetter conditions, or percent, in this case, it's decrease in the percent time across these time bands that we would expect to see these areas in drought. And in fact, we see those areas actually a bit wetter overall in general in the models. So a takeaway is, well, our winters are likely to get wetter. Now, summer is a different story. In the summer, we're actually seeing across the entirety of the state drier conditions, and by the end of the century, we actually see a very large uptick with a 10% increase in the amount of time we expect certain counties to be experiencing drought conditions. Now, in terms of the calculation of the drought index that we're using, the SPEI, it incorporates both the rainfall and also the evaporation driven by temperature. So as our summer temperatures warm moving forward, we expect to see more of this drought condition, mainly driven by that evaporation, that evapotranspiration. Sorry, I just want to make sure. Now, this also goes with what we kind of anticipate to see with the distribution of rainfall in general, especially associated with extreme rainfall. So when we look at model projections, we are starting to look at this system of kind of boom bust with rainfall throughout the state of New Jersey, where we're not changing the amount of rainfall we're getting too much, but we're changing when it's happening. And we're seeing these very intense periods of rainfall followed by drier conditions. And we're seeing that enhanced in some ways during our summer months, and we expect to see that more so moving forward. Now, these drought conditions have a number of downstream impacts and importance for agriculture, for local water supply, managing reservoirs, and the like. So we are hoping that this information can be used to help inform that. At the Resource Center, we're in the process of developing a more complete drought projection tool based on this framework that covers more scenarios, more time periods, and the like, that we hope will be useful to the folks here in New Jersey. All right, the second sidebar piece that we had was an evaluation of our greenhouse gas emissions targets in the state of New Jersey. So we put out a report earlier this year at the Climate Change Resource Center discussing this, and we're just focusing in a little bit on some of the key takeaways as a summary here. So New Jersey has two major greenhouse gas emissions targets. So the 2007 New Jersey Global Warming Response Act stated to reduce greenhouse gas emissions in New Jersey to 80% below 2006 levels by the year 2050. And in 2021, Governor Murphy signed Executive Order 274, which set an interim target of reducing our emissions to 50% of 2006 levels by 2030. So even though the 2030 timeline's sooner, the actual order to reduce the emissions by 50% came later in the timeline. And we wanted to ask, how do these targets compare with the necessary emissions needed to meet the 2015 Paris Agreement? And the language of that agreement is saying, broadly, we want to follow whatever means we can to keep temperatures as close to, by 2100, as close to 1.5 degrees C of warming as possible, preferably, or at least under 2 degrees C, but trying our best to meet that 1.5 degrees C of warming. Now, one of the issues we ran into is we wanted to compare New Jersey goals with the IPCC model projections as well as US goals. And they all use different benchmark years. So we had to convert those from the US goals being relative to 2005, in New Jersey goals relative to 2006, IPCC projections for emissions starting 2015. We just aggregated them all and converted them to all be relative to 2015. So if you were to look at US-wide emission reduction goals as of the most recent nationally determined contribution, as of 2024, the emissions reductions were by 2030 were somewhere in the ballpark of 44 to 47% of 2015 emissions, and then by 2050, basically aiming for net zero greenhouse gas emissions. Now in New Jersey, if we take our goals that we had in the last slide and convert those to be relative to New Jersey 2015 emissions, which was about 100.6 million megatons of carbon dioxide equivalent. So basically, if we take all of our greenhouse gases, whether they're methane or whatever, and put it in comparable units of carbon dioxide, we would have about a 40% reduction by 2030 and a 76% reduction by 2050 as our target goal. So how does that stack up? We looked at a few different scenarios from IPCC models that looked across scenarios that would say be close to meeting the 1.5 degrees Celsius of warming. And this would assume that New Jersey basically follows what the US models would need. So the IPCC doesn't have actual models for New Jersey itself, but it does nationally. So what we did is we took the national projection changes needed for the US to contribute to this global scenario, in this case 1.5C or 2C, and said, okay, New Jersey reductions would be proportional to that. So they would have a similar percent decrease. So we looked at, again, these scenarios that are close to 1.5 degrees C with various likelihoods, and then 2 degrees Celsius with various likelihoods of occurring. And so that's what's plotted here in this graphic. The black boxes actually represent our stated goals here in New Jersey. And our 2030 goal actually pretty well complies with the spirit of Paris. Basically saying, okay, that would get us somewhere between these two different 1.5 C scenarios, and would basically put us in the trajectory for meeting that 1.5 degrees C of warming by 2100. Our 2050 goal actually has us in between 1.5 and 2 degrees C. And one could argue that that would actually put us still complying with Paris, below 2C, but hopefully getting closer to 1.5 C. However, in many cases, a lot of these scenarios and a lot of the things to actually get to Paris would necessitate a net greenhouse gas emissions target. Basically, our emissions being equaled out by what is being sequestered away here within New Jersey. And currently, New Jersey does not have a net zero greenhouse gas target, so that probably edges this kind of evaluation closer to this 2 degrees C of warming trajectory. So without that, our evaluation in the report was New Jersey's 2050 goal is much more in line with 2 degrees Celsius of warming versus 1.5 C. So technically within the lines of Paris, but maybe not within the spirit of Paris. So with that, I want to kind of wrap up. I'll turn it back over to Marjorie, but I do want to say thank you to our team that put together this report, as well as our reviewer for the report, Ellen McCrae.
Thanks, James. So thank you so much to all of our speakers. What a great constellation of stars that we have with us here at Rutgers. I'd like to invite all of them to join us on camera for Q&A, and I'm going to look to Lucas Markson, my co-director, who's been following your questions in the chat, and some of you put them in the Q&A to kick off the Q&A. We'll try to get to as many as we can.
Thanks, Marjorie. All right, so I'm going to kind of jump around for each of you to try and answer some questions that we received. So starting with you, Dave, we received a question about the cloudburst rain events seem to be increasing globally. Do you track cloudburst trends over numerous years in New Jersey?
Yeah, that's a great question. And we know that a warming atmosphere can retain more moisture. For every 1.8 degree Fahrenheit change in temperature, the atmosphere has the potential of holding 7% more moisture. So one can look at that with the adjacent warming oceans as well and say there's more moisture available. So when a trigger exists, you can get more moisture out of the atmosphere in terms of downpours. So I like to say when it rains, it pours. The difficulty in looking at this over the long term is a long-term consistent database. And once you get before the 21st century, you're dealing with several dozen stations around New Jersey. Since that time, we have our automated weather network of 69 stations at njweather.org, and we have a volunteer group of observers called Community Collaborative Rain, Hail, and Snow Network, and we have 300 of them. So we're inundated with more observations, so it's very difficult to take those observations and put them in perspective of what happened 30, 40, 50 years ago. So I guess the best to say is we have more observations than ever, and we're catching these major rain events. There was 5 inches of rain the other night down in Mount Laurel. We saw 5+ up in Plainfield, North Plainfield area, and we've seen others back in 2024 down in Pennington. So unfortunately, we don't have a long-term record of a consistent data source, but we certainly have observations. And mind you, it goes back to 1999 with flood up in by Lake Pacon, Tabernacle in 2004. So it's not like we haven't seen these before, but it does seem we're seeing more of these events, but it's tough to put in perspective because we have so many more wonderful observations to track these events.
Great, thank you, Dave. James, next question is for you, and I'll allow Tony and Dave to chime in afterwards. Can you review if these findings from the current report differed from previous reports, and if so, to what degree?
Not substantial. This is more of a an update. So we do refine the measurements as we have them, as we do the various analyses or do the trends and etc. Sometimes the historical data gets reevaluated. We make sure we update those. But this is about adding the next year of data, or in the case of some cases, like the model projections, we have newer projections. We make sure we incorporate those. So it's not wholly revolutionary. It's just more an update on the evolution as we go along in this report.
Tony and Dave, do either of you have anything else to add to that or no? Good.
I'll just quickly add that, one of the things that was highlighted in 2023 was how much warmer 2023 was globally than the year before it. And so with another year, we see that unusual warmth of 2023 was followed up again with another unusually warm year, actually even warmer than 2023. But it is incremental. We're not going to be seeing big changes from one year to the next in our long-term outlook for where the climate is going.
Great. Thanks. All right, next question is to you again, Tony. So hopefully you can provide an answer to this. Will New Jersey's efforts to restore small and large hydrological cycles via regenerative land use change be included in future New Jersey climate modeling, given that water vapor is the dominant greenhouse gas?
So, there's a lot of misunderstanding when we talk about what is the dominant greenhouse gas. Water vapor is the dominant greenhouse gas, but water vapor can't change on its own. As Dave alluded to before, the amount of water vapor that the atmosphere can contain is determined by its temperature. So if we tried to put more water vapor in the atmosphere and the atmosphere wasn't conducive to receiving it, that water vapor would just fall out in the form of precipitation. So really, water vapor is not a driver of climate change, it's an amplifier of climate change, and it is responding to other causes.
Great, thanks, Tony. Dave, back to you. We had a question about if you could speak about the frequency of tornado and tornado warnings watches in New Jersey.
Yeah, we have not seen a trend in tornadic activity. Perhaps, and I've not looked at this, a trend towards more watches and particularly warnings, because warnings now are issued by just looking at Doppler radar when they see a circulation pattern that suggests there could be a tornado. In the past, before Doppler radar, you had to see a tornado in order to issue that warning. So again, inconsistency over time looking at this. But anyone who might want to look at every tornado that's occurred in New Jersey officially since 1950 can be found on the state climate website, njclimate.org. Every one of them is documented by time, date, strength. We have maps that you can look at it by month and year. And while we've had clusters of active years, the late 80s, early 90s, and the late 20 teens to this decade, there's no trend we've seen in New Jersey in terms of tornadic activity.
Great.
One last question, time for that, I think.
Okay, this one's going to go to you, James. There was a question about what part of our sea level rise, what part of the sea level rise we're seeing is due to sea level rise itself, and what contribution is from subsidence.
So here in New Jersey, historically, the biggest contributor to our observed sea level change has been subsidence. Our coastal lands are sinking over time in New Jersey, so we have our regional and global sea level effects that's causing some amount of rise, but our land is sinking over time. So we see this much greater rate of sea level change in here in New Jersey than other parts of the country or other parts of the world. You see a similar effect, for example, on the Gulf Coast near the Mississippi River. Looking forward, while that subsidence is going to continue to be a driving force of greater sea level change here in New Jersey, what we're looking at is changes to meltwater from, say, Greenland is expected to make a larger fraction of our observed sea level. So if you look at the budget in that. That is in the Science and Technical Advisory Panel report, those fractions are. And as Marjorie mentioned in the chat, we are in the process of working on an update to that report. I'm not going to say when that will be released, but it will have a similar breakdown of historically how those individual components contribute to our sea level rise on New Jersey's coasts.
So just to clarify, we expect the report will be released sometime this fall. We're hoping to get it out.
That's why I
any
thought I didn't want to put words in your mouth, though.
Okay, so thank you to Dr. Broccoli, Dr. Robinson, Dr. Shope. Thank you, Lucas. Thank you, Dr. Stringham. We are so grateful everybody was able to be on today's webinar. This has been recorded and it will be available. We'll send a note out to everybody when it is available, and you can find the report on our website. So that concludes today's webinar. Thank you all.